very beautiful question once again, which can be solved in the most easiest way possible without any usage of variables. Now see here, sir, this is what I want to teach you, sir. This is definitely what I want to teach you. Now listen carefully. Let us read the question. Reshma leaves her home at 9 a.m. every day and reaches office at 10 a.m. That means, let us understand statement by statement and then solve this particular question. That means, Reshma is traveling from home to office. Suppose, for example, from A to B. She will start from home at 9 a.m. and she will reach office at 10 a.m. That means, can I say that every day if she is traveling at her usual speed, usual time that is taken for her to reach the office is from 9 o'clock to 10 o'clock, she will usually take 1 hour. Every day usually she will take 1 hour to reach the office, right? 1 hour to reach the office. That means for entire total distance, if she is taking 1 hour, to reach half of the distance, she will take half an hour. That means she will be at midpoint of her distance at half an hour from 9 o'clock, which is 9:30 a.m. if she travels at usual speed, right? If she travels at usual speed, right? This is the first statement. Second statement, right? Second statement. Read the next statement. One day she left home at normal time. One day she left home at normal time. Normal time is nothing but at 9 o'clock itself she left her home one day and traveled the first half of the distance at 2/3 of her original speed. That means the first half of the distance she is not traveling at a regular speed. She is traveling at 2/3 of her original speed, right? She is traveling at 2/3 of her original speed. Now that is the second statement. Now think logically, sir. Think logically. If she is traveling at a regular speed from A to C and also from C to B, she will take 1 hour usually. Usual time she will take is 1 hour if she is traveling at regular speed from A to C and also from C to B. But from A to C, she is not traveling at regular speed. She will travel at 2/3 of her regular speed today because of some reasons. Because she is reducing the speed, she will not reach the midpoint at 9:30. She will definitely take more time to reach her midpoint. She will reach the midpoint after 9:30 sometime later. We don't know when she will reach midpoint. That we will calculate. Right? Now see here. Can I say that from A to C she is traveling at 2/3 of the distance? Yesterday, whoever the people who attended, they will understand this problem very easily. Distance is equal to speed into time. Speed is 2/3. So time will be nothing but reverse 3/2. The meaning of time 3/2 is nothing but denominator always represents initial or usual value. Usual time taken or actual time taken is nothing but actually or usually every day she will take 2 minutes to reach the office because the 2 is there in the denominator, right? 2 is there in the denominator. Usual time taken is 2 minutes, but today she took 3 minutes. That means she is late by 1 minute. She is late by 1 minute. But according to the question, usual time taken is not 2 minutes to reach the midpoint. To reach the midpoint, usual time taken is not 2 minutes. It is nothing but 30 minutes. 9 o'clock to 9:30. She will usually take every day 30 minutes to reach the midpoint. 2 is becoming 30. Multiply by 15. 1 also multiply by 15. 1 into 15 minutes is 15 minutes late. That means the meaning of 15 minutes late is actually every day Reshma will travel from A to B. She will start from home at 9 o'clock. She will actually reach at 10 o'clock. If she is traveling at usual speed, she will reach the midpoint at 9:30. But because today she is traveling at 2/3 of her usual speed for the first half of the distance, she will reach at midpoint not at 9:30 a.m. but 15 minutes later than 9:30 a.m. That means she will reach her midpoint at what time? 9:45 a.m. I believe that your understanding is very clear, sir. She will reach the midpoint today because of her slower speed at 9:45 a.m. What is the question? At what rate of speed should she travel at the second half so that she reached on time, she reached exactly on time. That means what they are saying is, because of some problems she reached office, or she reached the midpoint at 9:45 today, but they are saying that the second half of the distance she should cope up. She should cope up for the second half of the distance, and she should exactly reach on time. If she want to exactly reach on time, at what rate of speed should he travel the second half so that she reached office on time? That means earlier 9:30 she was reaching the midpoint. She was having 30 more minutes to reach office on time, which is at 10 o'clock. She was earlier having 30 more minutes to reach on time. That means if she is traveling at a regular speed or the normal speed, if she is traveling at her normal speed, she has 30 more minutes to reach on time from midpoint. That means the second half she has 30 minutes left. But because she did not travel at a normal speed, she is reaching midpoint at 9:45 and she has to reach at 10 o'clock itself. She has only 15 more minutes left for her right now. She has only 15 more minutes left. How much speed she needs to travel with is the question. Now see here, can you think logically like this, sir? Speed and time are inversely proportional to each other. That means if I increase the speed, time will decrease. If I increase the speed, time will decrease. Denominator or right hand side, 30 is becoming 15. It is divided by 2. Time is divided by 2. That means the speed should be multiplied by 2 because it is reverse. That means she should travel with double the speed. She should travel with double the speed so that she will still reach on time, although she has reached at 9:45 a.m. for the midpoint. Answer for this question is double the speed. That means when she is having 30 minutes, she will travel with the normal speed itself. If she wants only to reach in next 15 minutes, she should increase her speed. She should double the speed. Answer for this question is double the speed. Again, a beautiful way of problem solving, never seen way of problem solving, which you will definitely vote for this particular statement of mine. See the question, how beautifully you can solve. If a person increases his usual speed by 20%, he reaches office 15 minutes early. How many minutes will he be late to his office if he reduces his speed by 20%? Let us understand the question. If a person increases his speed, his usual speed by 20%, speed increases by 20% is 20 by 100, 1 by 5. What is the meaning of speed increases by 1 by 5? I told you multiple times. Denominator will always represent the initial value. Initial speed is 5 kilometers per hour. Final speed will be 1 more than 5. 1 more than 5 is 6. So speed is 6 by 5. If speed is 6 by 5, time will be 5 by 6. Again, just I explained in the previous questions also and in yesterday's class also. What is the meaning of time is 5 by 6? Time is 5 by 6 means denominator always represent the usual value or the actual value. Usual time taken is nothing but 6 minutes. Usual time taken is 6 minutes. But today he took only 5 minutes. That means he is early by 1 minute. But the question says that if his speed is increased by 20%, he reaches office 15 minutes early. Question says it is not 1 minute early, it is 15 minutes early. 1 is becoming 15. Multiply by 15. 6 also multiply by 15. Every day usually the time taken by him is 6 into 15, which is 90 minutes. Every day he will take 90 minutes to reach the office. This is my first statement. Come to the second statement of this question. How many minutes will he be late to the office if he reduces his speed by 20%? Now he is decreasing the speed by 20 percentage. That means initial speed is the denominator 5, final speed will be 1 less than 5, which is 4. Time will be reverse, it is 5 by 4. Meaning of time 5 by 4 means usual time taken is 4 minutes. Usual time taken is 4 minutes. But today he took 5 minutes. That means he is 1 minute late. He is 1 minute late. But just now we calculated, sir, usual time is not 4 minutes. Just now we calculated usual time is 90 minutes. 4 should become 90. Multiply by 22.5. 4 into 22.5 is 90. 1 also multiply with 22.5. That means if he is decreasing his speed by 20 percentage, he will be late to the office by 22.5 minutes. Very beautiful way of problem solving, which again does not require any stupid methodologies, kind of formulas based approaches, which can be so beautifully solved in this method. I hope the idea should be very clear, sir.